Hey guys, welcome back to lecture series on Z transform. For more videos, check in my I button here. Okay, you will get the more videos in my I button, complete playlist, and you can check as well. You can check in my description box. I uploaded plenty of the videos. So complete playlist on a linear differential equation with a constant coefficient, and afterwards Fourier sine, cosine, Fourier transform, and their inverse transform. So we have started Z transform here. So today we're gonna solve one of the important example. Find out the Z transform of Z of cos 2k plus 3. Okay, so we have to find out the Z transform for this cos 2k plus 3. Okay, yes, let's get to solve this example. Yes, so already we have learned, guys, two results, okay, for finding the Z transform. One it is for the sine, and another one it is for the cos. Okay, so we know the result for Z transform of a sine. Okay, we know the result for sine alpha k, cos alpha k. In such a form we learn the result. Okay, but as we can see here, we have cos 2k plus 3, it is present. Okay, cos 2k plus 3 it is present here. Okay, so for that we have to go for the expansion. So we have to go for the expansion of cos a plus b. Okay, so what is the expansion for cos a plus b? Cos a cos b minus sin a sin b. Okay, so you all need to know the expansion for cos a plus b. Let me write here cos of a plus b. Cos of a plus b can be written as cos a cos b minus sin a sin b. Okay, cos minus sin. Okay, cos minus sin. It is the expansion of cos a plus b. Why I have written, guys, this one? Because we know that we have the value for cos a cos b sin b in some specific value. Okay, but to 2k plus 3 it is like some sort of equation. We do not want that one. We want a single term which is present here. Okay, single term present. So that's why I expanded this term like this way. Okay, yes, and we know that Z transform of cos alpha x. What is the Z transform of cos alpha k? Let me write here Z transform of cos alpha k, and we have to take condition here. We need the condition for k also. Okay, k greater than equal to 0. So let me write first of all Z transform of, okay, Z transform of cos alpha k. Okay, cos alpha k and k greater equal 0. Okay, Z transform of cos alpha k. I proved that result in my previous lecture. Okay, so if you are interested to see this proof, go and check in my last lecture. Okay, yes, Z into Z minus cos alpha. Okay, Z into Z minus cos alpha, denominator completely Z square minus 2Z cos alpha plus 1, Z square minus 2Z cos alpha plus 1. Okay, comma, okay, we write modulus of Z which greater than 1. Okay, so this one is our required Z transform for cos alpha. Okay, yes, now we are going to apply this Z transform to our example. Okay, so it is very easier, guys. Okay, need to replace the values only. Okay, now see that cos a plus b we have here. So replace the value for cos a plus b into cos 2k plus 3. So what it will be? Cos 2k plus 3 can be written as cos 2k cos 3 minus sin 2k sin 3. How I have written this one, guys? Okay, now see that instead of a we have 2k, instead of b we can write 3. Okay, so cos 2k cos 3 sin 2k sin 3, and in the middle it is negative sign as it is. Okay, so replace this value instead of cos 2k plus 3. Okay, now how I am going to write Z transform of cos 2k plus 3? I am going to write cos 2k cos 3 cos 2k cos 3 cos 2k cos 3. Okay, minus sin 2k sin 3 sin 2k sin 3. Okay, cos 2k cos 3 minus sin 2k sin 3. Okay, this one is our required z transform. That means I written cos 2k plus 3 in expanded form like this one. Okay, yes. Now we have to apply linearity property for z transform. Okay, so what is the linearity property for z transform? It says that, okay, the linearity property for z transform, it says that, let me write the linearity property. Okay, that one I'm going to apply over here for solving this further part. Okay, yes. So linearity property, it says that z transform of a into f of k, okay, a into f of k plus b into g of k. Okay, so z transform of a into f of k plus b into g of k, it can be written as a into z transform of f of k plus b into z transform of g of k. Okay, okay, and also we can write this one as a into f capital F z plus b into capital G z. Okay, actually this one is the z transform now, so that's why I have written. Okay, and we know that z can be represented as a complex number, as we are looking z transform or a Fourier transform in a complex form. Okay, yes. So this one is the Laplace transform. This one is our linearity property that I'm going to apply over here for solving this z transform. Okay, yes. Now see that cos 3, cos 2k, sin 2k and sin 3. Okay, so when that sequence for 2k matters whenever we have k present here. Okay, yes, but whenever we don't have k, like a cos 3, sin 3, these are the constant term, guys. Okay, so we can take that constant term outside here, and under bracket we go for finding the z transform of cos 2k and the sin 2k. Okay, so apply this linearity property over here. Okay, so I'm going to write next step here as, okay, so what is the next step? It is coming. Okay, so cos 3, it is constant, we take it outside, cos 3 outside. Okay, cos 3 outside into z transform of, we want the cos 2k, okay, yes, minus sin as it is here, sin 3 as it is. Okay, and z transform of sin 2k, z transform of sin, okay, 2k. This one is our required expansion for this term I written here by using linearity property. Okay, now it is easier to find out the z transform of cos 2k. Now see that z transform of cos alpha k can be written as z into z minus cos alpha upon z square minus 2z cos alpha plus 1. Okay, similarly apply here cos 3 as it is here, z transform of cos 2k. 2k means alpha, it is equal to 2. Replace alpha as a 2 everywhere. Okay, so I'm going to write this one as a z, okay, into z minus cos alpha, z minus cos alpha. Instead of alpha we write 2 now. Okay, alpha k means 2k here, upon totally divided by z square minus 2z cos alpha, which is equal to 2 plus 1. Okay, so z square minus 2z cos alpha plus 1. This one is our z transform over here. Okay, minus sin 3. Okay, and z transform of sin 2k. Okay, sin 2k. Now we want the z transform for sin 2k also, guys. Okay, and we know that the z transform for sin alpha k. Okay, let me write the z transform for sin alpha k. I'm writing here because we need these two formulas, very much important here. Already explained how these are coming. Okay, z transform of sin alpha k when alpha greater than 0. Okay, so we write, okay, z sin transform of z sin alpha, okay, z sin alpha divided by z square minus 2z cos alpha plus 1. Okay, and modulus of z greater than 1. Okay, now see that denominator, it is both same here. You need to remember numerator, which is a z sin alpha. Okay, Yes, this one is the Z transform for sin alpha k. Z sin alpha upon Z square minus 2Z cos alpha plus 1. Okay. Yes. Now replace the value. Okay. So we have, instead of alpha, we have 2 here. So Z sin 2 upon Z square minus 2Z cos 2 plus 1. Okay. Yes. Z sin 2 upon Z square minus 2Z cos 2 plus 1. Okay, this one is our required answer. This one is our required answer, guys. Okay, yes, this one is our required Z transform for cos 2k plus 3. It is way easier, guys. Don't have anything, just need to remember only two result. One it is for the cos alpha k, another one it is for sin alpha k. Okay, remember these two results. It is way easier. Okay, I hope you all have understood my today's solution, which based on the Z transform for linearity property. Okay, yes, so nothing it is difficult here. I hope you all have understood. Okay, so I want you to solve some examples for your homework. Okay, let me write one example that you can try for your homework, guys. Okay, so it is similar like above one. Okay, these are important example coming in your in same exam. Okay, so find, let me write one example for your homework. Find cos of 17k plus 21. Okay, you can take anything 17k plus 21, and find Z transform of cos. Okay, cos of 17k, this one is a rounded bracket, guys, and this one curly braces complete. Okay, we want the Z transform. Okay, so find out Z transform of cos 17k plus 21, bracket complete, curly braces complete. Okay, this one is a homework for you all. Okay, find out this Z transform and tell me in my next lecture. Okay, or you can comment me in my comment section answer. Okay, so I hope you all have understood my entire solution here, and plus this example consider for your homework. Okay, so we stop here, guys. Okay, that is here for our today's lecture. If you want more detailed videos like this, guys, let me know in my comment section. Okay, I will come up with a similar videos, so you can refer these notes for your understanding. Okay, so that's it here for my today's lecture, guys. So thank you everyone for my today's lecture.